Hey everyone, in this video we'll understand one of the most important building blocks in machine learning, the loss function. We'll break it down from the basics, cover real life examples and see where and how each type is used. So let's begin. Before knowing about what exactly loss function means, first we'll know what is loss and what is function. Coming to the loss simply means a mistake or error, like how wrong a prediction is. Coming to the function, a function is just a formula or a rule that calculates something. So, a loss function is just a rule that tells us how wrong the model is and it compares the actual and the predicted value and gives us a number. So, here we have taken an example. This is a data game we used to play, right? So, here the actual value is the red point over here. This is the predicted value. Imagine it is a predicted value. So the difference between this actual and the predicted value is called loss function. So next, why loss function is important? Why do we need a loss function? So here is why. It helps us to measure the model's error, and without it the model wouldn't know how to improve. And during training the model adjusts itself to reduce the loss. So here the lower the loss, better the model's prediction. So we'll predict and calculate the loss and again we'll update it and repeat so that the model's performance, the efficiency will be increased. For example, think of loss function as a teacher giving feedback to the model. So every time the model makes the prediction, the teacher calculates how far it is from the right answer. So it will calculate how far it is from the actual one. So and tells the model you're this much wrong and you have to update this much. So that is how we use loss function and calculate it. Next, types of loss function. We have so many types of loss functions. Here we are going to discuss about few. One is MSE, which is mean squared error, and another one is MAE, which is mean absolute error, and another one is binary cross entropy and categorical cross entropy. So we use all these for regression and classification. So what comes under regression and what comes under classification, we'll see now. So here you can see a table. So in this table, the mean squared error and mean absolute error comes under the regression, and binary cross entropy and categorical cross entropy comes under the classification. Here the Huber loss and Hinz loss also few of the loss functions, but not used regularly. So we are gonna discuss the popular ones, most used ones. So, coming to the regression, we use for the to predict continuous values. Like here we have examples predicting house price. Imagine you want to buy a house and you'll see the price, right? So this month it would be something around 50K, 1 lakh or something. But next month it may increase. So it varies according to the time. So predicting those type of continuous values, we use regression. Coming to the classification, like spam versus not, like spam or not, yes or no, male or female, and those type of examples, we use classification. So these are the loss functions that comes under the regression and classification. Here we have to remember two things. One, we use regression when our output is in like kgs, rupees, degree centigrade, and all. We use classification when our output category is like yes or no, cat or dog, likewise. Next, now we'll see how loss function works mathematically. So here we can see the formula for mean squared error and also for the binary cross entropy. First we'll see the mean squared error. Here 1 by n sigma y true minus y pred whole square, which is a prediction, Like y true is called the actual value, and y pred, which is y prediction, is called the predicted value. And here n is the number of predictions we have to calculate. Another one is binary cross entropy, which is loss equal to minus y into log of p plus 1 minus y into log of 1 minus p. So here the y's we have are the actual label, like predicting 0 or 1. Uh, as we have discussed earlier, like male or female, in those type of classification, here the y label is like that. Coming to the p is the predicted probability between 0 and 1. So we'll quickly recap everything we have discussed. So a loss function is a tool that helps the model learn by telling it how wrong it is. So there are types of like regression and classification. We have discussed about few like MAE, MSE, and cross entropy and so on. Uh, So what we got to know about this is lower the loss will leads to the smarter the model. So till now we have seen the theoretical part of loss function. Now in this notebook we are going to understand what a loss function is and how to calculate it using Python. Specifically, we'll look at two common used loss functions. One is mean squared error and another one is mean absolute error. This help us evaluate how good or bad our model's predictions are, and we'll use a small data set like students. Here we have taken students marks to keep things super easy. So let's say we are predicting students marks, and the marks students actually got is the actual one, and the marks predicted by our model is the predicted one. So here we have taken two simple arrays. The first one is the actual one, which is the real data. Let's say it's marks scored by the students in a test. And the second one is the predicted one, is what our model predicted their marks would be. And now we'll calculate how close or far our model's predictions are from the actual values. So first, let's define the loss functions. Like first, we have taken here MAE and MAC. So MAE, which is a mean absolute error, simply takes the absolute difference between each predicted and actual value and gives the average. So, mean squared error does something similar, but it squares the differences before averaging. This means larger errors are punished more in MSE. So, now for the calculation, for the numerical calculation, and next coming to this. And here you can also see we are subtracting the actual with the predicted one and squaring it. So here now first we'll run the cells. Okay, now let's run this function, run this print statement. So we'll get a numerical value. So let's run this. Yeah. So here the mean squared error is 43.75 and the mean absolute error is 6.25. So lower the MSE and MAE, better the predictions are. Now let's visualize the actual versus the predicted values. So here, let's run this first, then we'll see. Yeah. So here, the blue line shows the actual marks and the red line shows what our model predicted. So as you can see here, some predictions are close Some are little off. So some are very close and some are little off. So this visual makes it easier to understand the difference. So the gap between the blue and red points is exactly what the loss function is measuring. So a loss function gives us a score that tells how far our model's predictions are from reality. So here MA is simple, it gives equal weights to all errors, and MAC penalizes bigger mistakes more. So lower loss equal to better model performance. So loss function act like a report card. So it giving a feedback to the model so it can learn and improve. So thank you for watching. I hope this helped you understand loss function clearly.